الله صلى الله عليه وسلم. So this Spanish where we left off. Okay.
F is a finite function whose domain is the letters A to E. The following table lists the output for each input in F's domain. So if x is equal to a, then, so if we input a into our function, then we output -6. F of a is -6. We input b, we get 3. We input c, we get -6. We input d, we get 2. We input e, we get -6. Build the mapping diagram for F by dragging the endpoints of the segments in the graph below so that they pair each domain element with its correct range element. Then determine if F is invertible. All right, so let's see what's going on over here. Scroll down a little bit more. So in this purple oval, this is representing the domain of our function f, and this is the range. So the function is going to, if you give it a member of the domain, it's going to map from that member of domain to a member of the range. So for example, you input a into the function, it goes to -6. So a goes to -6, so I drag that right over there. B goes to 3. B goes to 3. C goes to -6. So it's already interesting that we have multiple values that point to -6. So this is okay for f to be a function, but we'll see it might make it a little bit tricky for f to be invertible. So let's see, D points to 2, or maps to 2. So you input D into our function, you're going to output 2. And then finally, E maps to -6 as well. E maps to -6 as well. So that's a visualization of how this function f maps from a through e to members of the range. But also ask ourselves, is this function invertible? And I already hinted at it a little bit. Well, in order for it to be invertible, you need a function that could go from each of these points that can do the inverse mapping. But it has to be a function. So if you input 3 into this inverse function, it should give you b. If you input 2 into this inverse function, it should output d. If you input -6 into this inverse function, well, was hypothetical inverse function, what should it do? Well, you can't have a function that if you input a number, it could have 3 possible values, a, c, or e. You can only map to one value. So you actually can't set up an inverse function that does this, because it wouldn't be a function. You can't go from input -6 into that inverse function and get 3 different values. So this is not invertible. Let's do another example. So this is the same drill. We have our members of our domain, members of our range. We can build our mapping diagram. A maps to -36. B maps to 9. C, the inverse, D maps to 49. So let's think about what the inverse, this hypothetical inverse, input 25, it should give you E. Input 9, it gives you inverse function here. This is a 1-to-1 mapping. Each of the members of the domain correspond to a unique member.
Okay, inverse functions, in the most general sense, are functions that reverse each other. For example, if f takes a to b, then the inverse f minus 1 must take b to c, to a, b to a. Do all functions have an inverse function is defined? No. It's reverse. It's the input to 2 different outputs, 1 and 3. Speed is not a function because the inverse of h is not a function. We say that h is invertible. Here the function is invertible only if each has a unique output. That is, each output is paired exactly 1 input. That way, when the mapping is reversed, it will still be a function. Here is an example. check your understanding. Is a finite function that is stable. It's invertible. Yep. I don't think so. I- If we consider minus numbers, then minus 1 and 1 will give 1, and 2 minus 2 and 2 will give 4. So no, correct. Invertible functions and their graphs. What is this? Parabola or hyperbola. The graph of the function y equal x squared. You see, you got 2 is 4, minus 2 is 4. So we know that function but has a unique output of each output is better exactly. But this is not the case. Take the output notice. Okay. If you slide the horizontal and up down, that most outputs to the two inputs. So the functions. Let's consider the function. What is this? Hyperbola, parabola squared. Yep. Take horizontal line. It only ever intersects once, but this means that each exactly one another function is invertible. Think about is called horizontal test. In general, a function that passes the horizontal line test. The horizontal line test. Okay. Nope. Nope. Not invertible. Is G. It's invertible. Nope. So here it gets to same outputs here right here gets 4 and here gets 4 also. So our outcome is 2. No. Okay. Is this? Yes. Invertible. Okay. Exercise ready for practice. Finite functions domain is the letter A to E. Table is the output for each input. build a mapping diagram. Oh my god, are you for real? A and 20, range 20, B 6, 6, and C is 24, C is 24, I've got D is 2, and D is 1. As if invertible is invertible, check. Okay, not invertible, I got 3 minus 2. So A, B, A minus 3, and then B, C, D is minus 2. It's minus 3, minus 2, minus 2, and minus 2, minus 6. Okay, not invertible. Okay, 11, 15, 9, 13, 7, 11, 11, 15, 9, 15, 13, 7, 15, so, okay, yes, it's invertible. Yes, it's true. What's happening? A is 11, and then I got 15. B, sorry, that's for getting quick. C is 9. D is 13. Okay. 1, 2, 3, 1, 2. Not invertible. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Not invertible. 125, 4, 4. 1, 25, 4, 25. Restricting. I don't know if we should. I think we should go at this very fast. I don't know. No, I'm not sure. I think this is enough for one day. Well, the math. I don't want to go very quick in the statistics and the math because I still have a lot of things to go through in programming. I'm not sure till I reach Okay, this is it for today. Till I reach what? How long has this been going? Okay, because this precalc. I still have calculus 1, calculus 2, calculus 3. And other than this set, to jump into machine learning. Jump into machine learning, deep learning. So I buy them. Anyways, this is enough for today. Don't you think? How long has this been going? Is there a... God damn it. 16 minutes. I think it's enough for today. Okay. Because you still have GS, JS, and Python. Yep. Bye.